This is Electric Universe Eyes, and today I am going to do something kind of crazy. I decided I would burn a giant Lichtenberg figure into my laboratory desk. And it's not going to be just any Lichtenberg figure. It's going to be AC DC. Woo! Just like the band AC/DC, baby. But not really. It's actually with electricity. So I've got... Actually, I don't even have it plugged in. Let me fix this. See, look, now it's fixed. Plugged into my Variac. I've got control of 0 current to 130. All right, so from my Variac, I've got running to output of my 10,000 volt transformer. It's a neon power supply, 10,000 volts AC. That runs into a homemade rectifier bridge that I made that converts AC to DC using 4 diodes. Usually you see it in a diamond shape, but I mounted it on this piece of 2x4 here. One lead comes here, bridges to the 2 diodes, and I've got the other alternating current lead to this diode set. Alternating current running into these poles here, which will force positive current out this way, negative current out this way. So that's the diagram of a rectifier bridge if you want to build your own. And before we go any further, I want to say, danger, danger! I do encourage more people to experiment, but to do it safely and to educate themselves before they do it. So fair warning, this is my statement to all of you. Don't play with electricity. You can die. High voltage and specifically high amperage or high current can and will kill you. Don't be dumb. And I've got that cable coming all the way over here where the positive electrode is nailed into the table here. Back over here, I've got the negative electrode nailed into the table here. All right, on the other end of the spectrum, I've got my very first transformer. It's a 3000 volt, 30 milliamp neon sine transformer, alternating current. For those that want to know, the input is 100 to 240 VAC, 50/60 hertz, 5 to 25 watts. And the AC transformer is just going to be going out to this pole, and the other one wraps around here to this pole. I don't know what's going to happen, but when I did my last DC discharge on wood and made a Lichtenberg figure, it looked like a dragon. This is what it ended up looking like. The negative pole was on the left, the positive pole was on the right, and it looked like the head of the dragon. And the positive side would be the anode. So let's give this a shot. Before we start this stinky, steamy fun, because it's going to be vaporizing this wood as it's creating these Lichtenberg river channel patterns, what I wanted to do, I wanted to add in an element that not only goes through the alternating current, but also from the negative to the positive current. I want to add in a crystal element. And I'm going to be using 5 different types of crystals. First is going to be Epsom salt, which is magnesium sulfate. Second is going to be borax, sodium tetraborate, and baking soda, which is sodium bicarbonate. I'm going to use this water softener salt, extra coarse, and it is pretty thick stuff. Lastly, I'm going to use this synthetic black iron oxide. So I'm just going to create some lines going across here of each one. And then maybe I'll just label it and then we'll spray it down with some water and get started. That's what I got in this little spray bottle. Distilled water has magnesium sulfate, potassium bicarbonate, and potassium chloride in it. So let's just wet this first. So I basically want to wet between the poles. We'll go all the way between these poles here. And then I'll wet between the AC poles. Kind of like got a sideways cross, I guess, huh? And I'll just kind of circle this out, and then I'll let it soak in for a little bit. It's gonna be all right. You just kind of want to wet this top and let it soak in a little bit. That part soaks it up good. I've also had a bunch of different experiments. So you can see right there, I made a Lichtenberg figure there once. I got this is from AC. You can see those two. All right, well, pretty good layer on here, I think. I'm gonna wipe up some of this water where this electrode is because I don't want that to go through the cable. Let's first start out with the alternating current right there in the middle. So, and it's on. Turn this light out. I don't see anything yet. I'm gonna go ahead and turn on DC now. Oh, I see something going on right there instantly. You know, I forgot to put the freaking salts on there though. You know what? Wow, this is amazing and awesome. Let's stop. Woo. All right, let's put the salts on. First up is gonna be the water softener salt. And I think I'll just
make sure everything's off before I go, okay?
I'm gonna do water softener salt right here. Get that in the line right there. All right, next we'll do Epsom salt. All right, here's borax. And you ask, what's the point of this? Well, salts have everything to do with the pH of the earth.
And electricity.
You can measure voltage by what the pH is of something. So anyhow, I'm not talking about pH today. I am looking at running this with a charge going through it, alternating and direct current to see, does it do anything to each of these individual crystals? Next one is gonna be baking soda. Try to put a fair, even amount compared to the other ones. All right. All right, there's my baking soda. And last but not least, the black synthetic iron oxide. And I think I'll just go on here, on this side. Oh man, that's real close. That's real close, man.
That's real close, man. That's real close, man.
Oh, it might be all right. It's gonna have to be all right. All right. Well, let me get my trusty little scraper over here. Merged them. That's just gonna be too bad.
Too bad.
So this is synthetic black iron oxide. It's iron powder. So, all right, here's what we got. This is gonna be interesting. I think what I'll do is, everything's kind of drying out now. A little bit damp on this side, but I'm gonna go ahead and moisten this up. You can see that iron powder just melt out like that. See the water softener. Epsom salt in the middle. Borax here. And then we got baking soda. All right, so let's start off by turning on alternating current again.
And I'm gonna turn the lights out again for this. Hello.
Check out my experiment. I got AC going this way. I got negative and positive and DC going that way. This is all wet. Black iron oxide, water softener salt, Epsom salt, borax crystal, and baking soda.
Can you be extra and get some fire safety?
Yeah, I can.
All right, I've got everything set. That's had a chance to soak in. It looks like it's still moderately wet, but I'm gonna spray a little bit more just right on top, just to create another dielectric barrier layer.
So the idea is having a water table under the ground.
All right, so we're gonna turn on the 3000 volts alternating current, which are these poles. And that is on. not sure I see anything. All right, let's turn on the 10,000 volts. And that one lit back up again. All right, it's about to get stinky. Ooh, and that side lit up this time too. All right, I'm gonna put my mask on now.
So that's the DC direct current positive side, the anode. And this is the cathode, the negative side. Let's turn off the light. Happened. Interesting. It got interrupted, I guess, or it. Now let's try to reset it. Ran out of moisture. Let's try the 3,000 volts. I still haven't seen anything out of that one. Needs more moisture. All right, let's spray it some more. All right, let's start with DC. Turn the AC on too. Too wet now. Starting to get some action over here. Pretty. And look at this. It's bubbles. Okay. You want to spray it? Sure.
Is that that?
Yeah. Now the magic happens when there's the right moisture level. Because there's when it's between the layer below it and the layer above it. So as it starts to dry out and get to a certain moisture level, then it starts to vaporize. But if there's too much water, it just uses the current it uses the water to travel over the surface of the water. But it's when it starts to absorb into the wood, it creates these different layers. And it should start to arc more and more. This is the area we want to kind of keep wet if you want to spray this area. Yep, perfect. Try to keep that connection. Ooh. Yeah. I'll be interested to see what happens when it gets over here.
Me too. It looks exciting.
I think these are too far away. All right, this is taking a long time. I got it really saturated, which is the problem. But again, current's been running through it this whole time, and you can see where it's drying up. You know, that is from a prior experiment, so that's not from this, but that will probably connect. the ring of fire. I went down through the burn, the ring of fire. Went down, 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 and the flames went higher. And it burned, burned, burned. The ring of fire, the ring of fire. Come on, man. That one's growing a little bit. That one's making it. Not to take you away from that, but I had that just sitting over here on that setting, and that's what it's measuring. Black just right there on the outer ring, red over there. I like the negative side a lot more. See, it's actually carving and vaporizing out a canyon. And this one, if you notice, is rising up. It's bubbling up. It's mounding up. It's pulling up. You notice that? So that's the positive side, the anode. And this is the negative side, the cathode. A lot prettier. So I would say features like the Grand Canyon or Palo Duro Canyon was the negative electrode or the cathode in a system. Let's set this back down. See, watch this grow. Let's work out today. Getting on my wires. Gotta go through me, huh? There we go. Had to suck that smoke off somewhere else, kept coming right towards me. Woo! Yep. Got this other side becoming active over here now too. There you go. Look at this side. Went into my last Lichtenberg figure here. Burned right through that. The river runs through it. Ah, I get it. You see how it's just branching off in whatever direction it wants to go? See the branches? Oh, it finally started, yes. AC is in the house, baby. Oh man, I'm so happy. I was wondering when the AC was going to kick in. The DC, the 10,000 volts has just been taking priority. But I think now the surface area has dried up enough in this area and over here, it's finding some sort of conductive pathway through these layers. And now these guys are connecting, so this is cool. I don't know what's gonna happen, but it's gonna be awesome to find out. Baking soda is usually what you want to mix with water when you're doing wood burning art or experiments with high voltage electricity on wood to make these Lichtenberg patterns. So this first layer right here is baking soda. It'll be cool to see what happens here in a moment. This guy's still going to town. We don't have anything over here on the other pole for the AC electrode. The negative pole still doing its thing. So, let's focus on this guy. I'm going to set up something to record it. So the AC always seems to just do more of these big fat tree structures, just spreading out instead of towards each other quite as fast as DC. Now I'm going to move over to the anode, because you can see it's grown about that much since we were over there last. Turn this light off. I hear something sizzling. Something over here sizzling. I don't know what it is. That's how valleys and rivers are carved into mountains. That's what that noise is from, too.
All right, it's already been a long time, and this has not gone very far, but it's pretty cool. I think what I'm gonna do is turn everything off, and I'm gonna come back tomorrow, and we'll re-wet it, and then start it again.
And see what happens.
So next time will be part 2.
Thanks for hanging out again, folks.